Hello everyone, it's been a long time since I uploaded my last video because I had a period of midterms, but now I'm ready to make new videos for you, and today's topic is Cartesian product and planes and lines. So before we start solving problems, let me maybe remind you what is planes, what is lines, and what is Cartesian product. So suppose you have some point A, and this point have coordinates x naught and y naught. And now we are talking about R2 dimensional space. And how you can construct a line. You need directional vector. This vector called P, which has coordinates P1 and P2, and the line L is x, which equal to our point A plus directional vector multiplied by t, where t belongs to R. So it's actually really easy. So look, this is line, and this is some point A, and you just add directional vector P, and P can be bigger or smaller, so by t you multiply it, and if t is negative, it goes this side. So I hope you understand what is line. So now let me actually, you can write it in different cases. So you might write as like this: xy is equal to x naught y naught plus p1 p2 multiplied by t, where t belongs to R. So this is coordinates. Look, x naught y naught is coordinates of A, p1 p2 of vector P, and if you want, you can it's actually linear algebra. We study calculus in this video, but it's actually looks like linear algebra. If you multiply it, you will have such system that x is equal to this one and y is equal to this one, and of course do not forget that t belongs to R. And if you divide divide everything by if you get t in any side, you can write L in this case like x minus x naught divided by p1 is equal to y minus y naught divided by p2. This is all equations of lines, but in different notations. So how you got this one? You just switch x naught to left hand side, and divide by p1, and you do the same in this one, and just t is equal to t. So I hope you understand. Okay. And now let me talk a bit about Cartesian product of a plane. It's really important to understand to solve today's problems. So look, what is Cartesian product? Suppose you have plane. You have plane like this. It's plane. And now let me write it a little bit more. Like this, maybe. Like this. Yeah. So this is plane. This is plane P. And what you have? You have normal vector. Normal vector is 19 degrees. Is orthogonal to our plane, and this is called R with coordinates A, B, and C, and you have this point M0 with coordinates X naught, Y naught, Z naught. Yeah, and we now we are talking about three-dimensional space. As you can see, we have three coordinates, so this is R3, and for you have also some vector Q with coordinates Q1, Q2, Q3. You have another one P with P1, P2, P3. It doesn't matter how you write it. You may write this symbol or does not. It's not really matter. And also you have M with these coordinates. And what is actually Cartesian product? Cartesian product is Ix plus By plus Cz plus D and is equal to 0. Yeah, this is called Cartesian product. Yeah. If we, for example, want to check if some point in our plane, we can substitute this point into our equation, and if it's equal to 0, then it belongs to our plane. Now I will not erase it because we will need it. Now let's solve exercises for more clear explanation. So number 1, find the equations of the line passing through the point A 1, 7 and orthogonal to the line containing points B 0, 3 and C minus 7, 0. So look, we need to find equations of this line which passing through the point A and it's orthogonal to line. This line is orthogonal to this one with coordinate with points B and C. So what we can do, we can write vector BC, and how we can do it? We just wait, what? Let me actually save it. And let me open it because I will need my desk one more time. Okay, so let me explain you. If you have x, y, yeah. Oh, if you have y and x-axis, what you can do? If you would look, let me on the graph explain you how we can get BC vector BC. If you have point 0, 3, so this point, and minus 7, 0, minus 7, 0, then what is vector BC? BC, this one. And it's minus 7, minus 3, right? Look, it's B, and this is C. So BC, it is minus 7, minus 3. Look, if we will move from our beginning, minus 7, minus 3, it is this one. And these vectors are the same. And actually, these numbers are quite maybe difficult to understand. So if you have point 2, 2, 0 and 5, 0, yeah, let's show it on the graph. X, Y, so 2, 0 at this point, different notation of course, and B is this point. So how you can find vector AB? AB. What is this vector? It's actually coordinates of vector B minus coordinates of vector A. 5 minus 2 is 3, and 0 minus 0 is 0. So look, it's 1, 2, 3, 4, 5. So vector AB, this vector, is actually have it's actually 3, 0. I hope you understand. So we found vector BC, and now we need to find what we need to write equation of the line. We need to take point and directional vector. So if we, as we can see, this line is orthogonal, so we need to find orthogonal vector to BC. How to do this? How to do this? If you have wait. If you have vector P with coordinates P1, P2, so orthogonal to this one will be P2 minus P1. Yeah, you know. So if you write it, I don't know, A with coordinates 2, 3, yeah. So 1, 2, 1, 2, 3. This is this one. And what is orthogonal? Orthogonal is minus 3, 2, minus 3, minus 1, minus 2, minus 3, minus 3, 2, right? Oh, no, it's actually, wait, P2, and minus P1, minus 2. So 3 and minus 1 minus 2. So 3 minus 2 is this one, right? And as you can see, they are orthogonal, 19 degrees between them, 19 degrees. This is angle 19 degrees. This is 180, and this is 19. Okay. So we have vector BC, and we can find orthogonal. So it is 3 minus 7. And now we can construct line because we know point A and directional vector. I already discussed how to do this. Okay. I hope this task is clear for you. So find the equation of the line containing the height of the triangle ABC from the vertex A, and we have points ABC. So this is triangle ABC, and his height is this one. Yeah, it's 19 degrees there, and it's pretty same task. You can just find BC is equal to 3, 12, and this is vector BC, and you need to equation of line, this line. So you already have point A, and you need directional vector. Directional vector is orthogonal to vector BC, so you find it and write equation. That's all. So next task is actually a bit of tricky. Find the area of square, the size of which are on the lines. On the lines. We have two lines. And look, coordinates before x and before y are the same. That means that they are parallel. Yeah. So they are in the same direction, you know. So this is L1 and L2. And you need to find square, the size of which. So you can find distance between these two lines. Distance is d minus d2 is modulo, of course. And so 24 minus 4 is 20, and square root of coefficients before x and y. So I hope it's clear for you, and d squared is this one. Next task. Find the point A which is symmetrical to the point with respect to the line containing points B and C. We can do it by drawing graph. This is our graph. This is point with coordinates 1, 1. Look, 1, 1. And symmetrical point with respect to the line. Let's draw this line. This line is given by 2 points. So 2 and 3 is 1 point. 2 minus 2 is second point. So actually this line is vertical. This line is vertical. We have this point and vertical line. And look, symmetric. I hope it's clear that A prime is symmetric to this one. So this is A prime. What is coordinates of this point? 1, 2, 3, and 1. So 3 and 1, this coordinates, this is answer. I hope it's clear. And now we are moving into Cartesian product. This one. Find the equation of the line containing the point A and perpendicular to the plane, and plane is given by Cartesian product. So need to find equation of the line. This line contains point A, and this line is perpendicular to the plane. But look, you remember, right, that if you have a plane given by Cartesian product, then the normal vector with coordinates a, b, and c. So this is actually coordinates of this vector. Look, we can write it. Once again, we have point and directional vector. Then you can write equation of the line. That's all. But this is three-dimensional space. This may be difficult with this, but it's really easy. Now we are moving to Cartesian product, and actually I forgot to draw something, that if you have Cartesian product, for what I wrote Q and P, that means that you can find Cartesian product you can find it by solving this determinant from linear algebra. This is P1, P2, and P3, and there are Q1, Q2, and Q3, and this determinant is equal to 0. You just put two vectors which are in your plane, Q and P, as rows, of course, and x minus x naught. X naught, it is some point in our plane. So back to our problem. Find the Cartesian product of the plane containing the line and parallel to the line, this line. Okay, we have plane, and this plane containing this line. What does it mean that this containing this line? As you remember, these coefficients in denominator is actually P1, P2, and P3. And so we can write a vector P. It's one vector in our plane. And this is parallel to line, and this line is P with these coordinates. And they are parallel. That means that they are both in the same plane. So we have two vectors in our plane and point A. Point A coordinates this one. Z is equal to 0. So this is point A. So now you just write denominator, yeah, and you solve this determinant, and you finally got this Cartesian product. So let's move. Find the Cartesian equation of the plane containing the points A, B, and parallel to the axis. So you have plane, you have 2 points A and B. Of course, you can find vector A, B. I already told how to do this. You just 0, minus minus 2, it's 2. 10 minus minus 5 is 15, and minus 3 minus minus 3 is 0. So this is vector AB in our plane, and parallel to the axis. The axis we can just write that this is this vector, like, yes, this is the most common vector in which parallel to the axis, and it's also in our plane. So, and also we have point A. So the same as in previous task, we find determinant and get our final Cartesian product. And look, there is such case where z is equal to z multiplied by 0, so we don't have z there. Find the volume of cube whose faces lie in planes. We have two planes, and we need to find cube. Okay, so we know the formula for distance between planes. This is formula, and just substitute our numbers and got this one. It's cube, so the volume is equal to distance in cube. You can calculate it, but I'm lazy. Next task, find the Cartesian equation of the plane, all points of which are equidistant from the points A and B. So, when you draw a picture, it's quite easier to understand the whole task. So you have points A and B, and you need to find Cartesian product of the plane. And look, this plane is equidistant from points A, B. So whenever you take any point, for example, this point, the distance will be always equal. So, okay, you can find vector AB by 2 points. And what is M? M is the middle point, and it's actually x1 plus x2 divided by 2, y1 plus y2 divided by 2, and the same situation with z. So you find M, this point, which belongs to our plane. AB is normal vector, as you can see, because I think it's quite trivial, yeah? And so, because it's normal vector, take a look at our picture. This is normal vector. So our plane, our Cartesian product is have these coefficients. Yeah, and we need only to find D. And how we can do it? We can just substitute M to D. We have point M in our plane, and we need to find D. So substitute D is equal to this one and divide everything by 6. So this is our final Cartesian product. This task is really easy. Find the distance between planes. We already solved this. So distance by this formula. I hope it's clear. And final task. It's final task. Find the Cartesian equation of the plane containing the line and perpendicular to the plane. So this is our plane. From this we need to find Cartesian equation. And this is perpendicular. These planes are perpendicular. So we found normal vector from this one by these coefficients, and this is actually in our plane and P and point. So two vectors and point, that mean that we can find Cartesian equation by determinant. So we solve this determinant and find final result. This is just calculations, so do not need to mention it. So that's all for today. Thank you for watching, guys. Like and subscribe to my channel. If you have some questions, write me in the comments. Of course, I will answer you. Goodbye.